Hello and welcome back to AP Pre-Calculus. Today's topic is topic 1.8, rational functions and their zeros. All right, so recall that a rational function is a function that has a polynomial function on the top and a polynomial function on the bottom, where the bottom has to have an x, okay? So let's go down to these two important traits down here. So we have this function, f of x. It has function g of x on the top, it has function h of x on the bottom, yada, yada, yada. So as long as there are no factors in common, so if we factored g of x and factored h of x and nothing canceled out, so no factors in common, then we know f of x has zeros when I set the numerator equal to 0, and it'll be undefined where I get x's that make the denominator 0, or h of x equal to 0. Remember, we call these vertical asymptotes if they do not cross out, okay? So since we're trying to find zeros, we're going to have to solve, okay? So in this case, we're going to talk about solving inequalities. It doesn't matter if it's an equal sign or it's a greater than or less than, doesn't matter. But we need to identify both the zeros and undefined values. So we got to find everything, okay? So the first thing we're going to do is we're going to make sure that it's equal to 0. We're going to make sure that we have a single rational function. We can't have a fraction plus 3 over here, something like that. We've got to make it a single rational. And then we're going to set the numerators and the denominators equal to 0 and solve them. Most likely we're going to have to factor, but that's what we do. And then we're going to create our sign chart that we learned earlier in these lessons. Okay? We're going to mark all the values where the denominator is equal to 0. So we make sure that we never include those. So like open circle type ideas. All right? And then we're going to test a value in between each of our intervals to see if the values are either positive or negative, right? Remember, positive means above or greater than, negative means below or less than. And then we're going to interpret that and create our interval notation. Let's go ahead and move this up so we have a little bit of room to work. All right. So this one is nice because it's already has it equal to 0, or the inequality to 0. So we need to set our numerator, our x minus 2, greater than or equal to 0. So that's going to give us a 2, right? And because of that equal sign, we can include it. And then we're going to set our denominator equal to 0. And these cannot happen. I'm just going to go ahead and put an equal sign. It doesn't really matter. So we got a negative 6 and a positive 3. All right, so here we are. I'll put a 0 right here in the middle, okay? So now I'm going to put these numbers on the number line. And it doesn't have to be to scale. It doesn't matter. Negative 6 is over here. I'm going to do it with red because negative 6 is a bad number. And then 3. I'm going to also do it with red because that's a bad number. That makes the denominator 0, and we can never have the denominator 0. But the 2, I'm going to do in green because we can have 2 because it says greater than or equal to 0. So I'll put my 2 down here. All right, now we're going to select a number in these intervals. And I got several intervals. I have an interval from negative infinity to negative 6, negative 6 to 2, 2 to 3, 3 to infinity. I have to find a number in each one of those and test to see what I have. So I'm going to pick negative 10 out here. If I pick negative 10 and I put it in here, that's going to give me a negative on the top. When I put it into the first factor in the denominator, I'm going to get negative 4, so that's a negative. And I put it in there, I get another negative, negative 13. So I got 3 negatives. This whole thing will be negative. All right? I'm going to pick 0 for the next one. When I put 0 in the numerator, I get negative. I don't really care what the number is. It's just a negative. When I put it in the denominator, I'm going to get a positive for the first factor and a negative for the second factor. That makes a positive. In between 2 and 3, let's do 2.5. If I put 2.5 in the numerator, that's going to give me a positive 0.5. 2.5 plus 6 is 8. That's positive. And then when I put it with negative 3, it's actually negative. So this whole thing up here is negative. And then last but not least, I'll pick 10 again. I love 10. Excuse me. I put it in the numerator. I get 8, so that's positive. The first factor, 16, that's positive. Second factor, 7, that's positive. All positives make a positive. So we are looking, where is this function positive? Well, it's in between -6 and 2. So I'm going to go -6 to 2. Can't use -6 because that's a horizontal, that's a vertical asymptote, but I can have 2, and I'm going to union that with 3 to positive infinity. And I can't have 3, and I can't, positive infinity is not even a number. So there's my answer for the first one. Let's give ourselves a little bit more room on this one. So there we go. All right. So let's do the top. X squared minus 4 equals 0. That means x minus 2 and x plus 2. Could you just move the 4 over and done that? Yes. So I got 2 and -2. All right. This time, however, we cannot be equal to. All right. So we got to be careful with those two numbers. And then over here, we'll do the denominator, x squared minus 10x plus 25. That's going to give me a couple of x minus 5. So we'll call it x minus 5 squared equals 0. That's going to give me a 5. So here we are on this guy. I'll put 0 in the middle just because I always like to have 0 on there. And then I'm going to do red for everybody. So over here at -2, over here at 2, over here at 5. That means I don't get to use brackets at all in our interval notation on this one. All right. So now we're going to pick a number. Remember, I like -10. And I'm going to put it up here. Well, hold on a second. There. Let's put -10 in. Let's see what happens. When I put -10 in, I get -12. So negative times -8, negative, -15, -15. Gives me 4 negatives. That's a positive. So I'll put a positive over there. I'm going to put 0 in. That's going to give me a negative, a positive, a negative, and a negative. Well, that's going to be negative. Let's put a 3 in. Now, you can pick whatever numbers you want here. It doesn't matter. 3 is going to give me positive, positive, negative, negative, right? I believe so. That's going to give me a positive. And then if I put 10, positive 10 in, that's going to give me a whole bunch of positives, I think. Positive, 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 positive. So you might be thinking that it just flip-flops back and forth. And sometimes it does, but you just notice that this time it did not. And just a little hint, it's because of that guy right there. But we can talk about that a different day. So we want to know, where is this less than 0? Well, the only numbers on here that are less than 0 are negatives. So from -2 to +2, we are a negative. There you go. All right, example 3. I can't really set 2 equal to 0. There's nothing to solve for, so don't worry about the numerator if it doesn't have an x. But the denominator, I go x minus 3 equals 0, so x cannot be 3. When I come down here, I'm going to put 0 on there. All right. 3 is a bad number, so I'm going to use it. Wait a minute. I only have 2 sections here to cover? Well, that's going to be easy. So I like to use 0 if it's an option. So if I use 0, my numerator is going to be positive no matter what because there's no x. And my denominator is going to be negative because 0 minus 3 is -3. That's going to give me a negative. Let's try, I don't know, 5. I know I didn't use 10, right? Positive. And then 5 minus 3 is 2, positive. So that's going to be positive. So where are we above 0, greater than 0, or positive? That would be from 3 to positive infinity. And because 3 would make a 0 in the denominator, we cannot include it. And we can't include infinity because it's not a number. All right, pause the video. Give example 4 a shot. And then when you're ready, start it back up and let's see what we got. All right, we're going to take the numerator, 4x plus 8 equals 0. Little math magic, we get -2. And that's a good number because we have or equal to. Take the denominator, set it to 0, gets -5. That is a bad number because we cannot have a 0 in the denominator. So let's go ahead and put a 0 here in the middle. I like it. So I'm going to use a green line for -2, -2. I'm going to use a red line for -5, -5. And now we're going to just start picking some numbers. So I'm going to use -10 out there to the far left, because that's what I do. -10. That would give me a -30 something, which is negative over -5, negative. So out here, it is positive. Let's try -4, all right? If I put -4 in for the x's, I get like -8 over +1. That gives me a negative. And then we're going to try 0, because we always try 0 if we can. That's going to give me +8 over +5, which is positive. And we are looking for where is this going to be negative, because we are less than or equal to 0. So in between here, -5 and -2 is where we are, all right? But we cannot have -5, so this would not be right. That would be bad. So we're going to put a parenthesis, and we're going to put a bracket because -2 is okay. There we go. All right. Again, pause, give number 5 a try, and we'll see what we have. Okay, what you might want to do is put x plus 2 and x plus 2 if you want to, all right? But you don't have to. So I'm going to set my numerators equal to 0. So I got a good number at 1, a good number at -2, and then onto the denominator, x minus 2 equals 0. So +2 is a bad number, okay? So let's go here, put our 0 in the middle, put a green at 1, put a green at -2, and put a red at, oops, I don't know why it's not done, at 2. All right, so now we get to go back and do our numbers, and I'm going to do -10. So what you could do is what I'm going to do, I'll put -10 right here, and I'm going to go, well, that's going to be a negative, and then it's going to be a negative squared, which is a positive. So that's why I thought maybe you would want to do 2 of them, because that's just weird. So you could do it like this, and then on the bottom you have a negative. That gives me 4 negatives. That makes that a positive. We're going to try 0. That's going to give me a negative, a couple of positives, and then what do we got down here? A negative. So that gives me a positive. Try 1.5. Positive 1.5 is going to give me a positive, then a couple of positives, over a negative. So that's going to be negative. Oh, got to put 1.5 here. And then I'm going to use +10 down here. Last but not least, that's going to give me a whole bunch of positives, right? And that's going to give me a positive. And again, we're used to it going back and forth. A positive, a negative, a positive, a negative. But if you'll notice where it doubled up right here at -2. And notice again, we had an even exponent with it. There's a reason, okay? So what is our answer? We want to be greater than the 0. We want to be positive. So man, we got a lot of things here. So I'm gonna write it up here. So from -infinity to -2, 2 is good, boom. I'm going to union that with -2 to 1, and those are both good, boom. And then union that with our last one of 2 to +infinity. 2 is bad, so we put a parenthesis. +infinity is not bad, it's not a number, so we can't bracket it in, okay? So there's your answer. Stop the video, give 6 a try. All right, again, I'm going to go ahead and write it like this. I think that makes a little bit more sense, at least in my head. If you can do it with this exponent there, feel free. All right, so all I got to do is set the denominator equal to 0, and I get x minus 1 equals 0. So that's a 1, and that's a bad number. So we're going to go ahead and put 0 in the middle. We're going to do a red line here, and it's going to be 1. Okay? Now notice we got that squared. I wonder what's going to happen here. So we want to be less than 0. So we want negatives. So let's pick some numbers. I don't have to use -10 this time because I have 0 right there. I love using 0. So if I put 0 in, the top is always going to be positive because it's a 1. The bottom is going to be negative and negative. That makes a positive, right? I don't know why I did it in red down there, but it's okay. All right, let's do it again. I might use red to go there. Let's use 5. I haven't used 5 in a while. So that's going to be positive on the top. And then it's going to be a 4 and a 4. So those are both positive and both positive. And this is positive. Oh, what? Let's go back to black. This is positive, right? I want it to be negative. We have an or equal to 0, but this will never be 0 because to be 0, we have to be able to make a 0 in the numerator, and the numerator will always be 1. So that's an issue. I believe the answer to this guy is no solution. If you were to graph this in Desmos or on your graphing calculator, this graph would never fall below the x-axis. And there I provided the graph for you. It did not go below the x-axis, so no solution makes sense. Okay, our last example is a rational function in graph form this time. So what we're trying to find out is where is the function f less than 0 or equal to, greater than 0, or greater than or equal to 1. Okay, so let's go ahead and give that a shot. So the first one, I'm looking for where is it negative. And I can see some negative, like all of this stuff here is negative, all of this stuff here is negative. So we got to figure out what is that interval. So it looks like it's going to get really close to -3, but it's not going to touch it, to -1. And because it's or equal to, I can be at -1, but -3 is a vertical asymptote. That means that denominator made a 0. So that's there. And I have to union that with the other red part there, that is 2 to 3, and I can touch 2 because it's equal to, but I can't touch 3 because it's a vertical asymptote. Okay? All right, let's move on to the B, where we have to be positive. Well, positive is all of this area, and this little bitty area over there. And there's no or equal to, so we definitely cannot have any brackets. So let's see what we got here. So I'm going from -infinity to -3. I'm going to union that with -1 to 2. I'm going to union that with 3 to infinity. All right? And last but not least, where am I greater than or equal to 1? So where is the y line equal 1? It's this horizontal line right here. And it's a horizontal asymptote because that left and right side, they flatten out as they go out to the infinities, right? So where am I above that? That will be the two outside ones. So from -infinity to -3, union with 3 to infinity. All right, we did it.